Hey there, Math Hoppers! In this video lesson, we are going to learn how to verify trigonometric identities. When you're given a trig identity, what you're given is a fairly ugly looking trig equation, but you're actually verifying to see whether it's really an equation or not. You have to verify to see if the left side of this equation actually equals the right side of the equation. So you're not going to see the equal sign and say, yep, those are equal, check mark, good. You're going to need to show the work to prove the left side equals the right side or vice versa. So, for example, if you were given this really simple identity, 1 over cosecant of theta equals sine of theta, you would use your reciprocal identity and rewrite 1 over cosecant theta as sine theta and see that they are in fact equal. So, what makes these super frustrating? Well, just like when we simplified trig identities, there is not a single defined set of rules or steps that I can give you that will work to solve each problem. However, like simplifying trig identities, there are guidelines to follow that will help you through these problems. First and foremost, you have to work one side of the equation only. You're not going to be manipulating or changing both sides of the equation. You're going to work one side. I say work the more complicated side of the equation or the uglier side of the equation and simplify it to match the other side. Second, you're going to look for all of those patterns in algebra that we've used throughout high school. Look to see where you can factor an expression, where you can add fractions, and yes, that will mean finding like denominators. Look for where you can create a monomial denominator where there isn't one. Maybe there's a binomial in the denominator, but you can create a single term denominator. Look for places where you can square a binomial. All of those little patterns and things you're used to in algebra will come up in these problems. Of course, look for where you can use your Pythagorean identities and your fundamental identities. These are going to be the crux of these problems. Make note of what you're trying to create. So say you're working the left side. You're manipulating the left side to match the right side. Make note of what's on the right side because you want to say, all right, I have to create that expression. What functions will work well together to get me there? Remember, sine and cosine work well together, secant and tangent, and cosecant and cotangent work well together. You have to know what you're trying to create before you really start manipulating things. And if all else fails, like before, if you don't see an immediate relationship, try rewriting everything in terms of sine and cosine, and you will likely find a relationship form. All right, so I keep talking about these identities. These are the identities you really have to know. Remember your Pythagorean identities? They really all stem from sine squared plus cosine squared equals 1. You can get all of the other Pythagorean identities as long as you know this one. You can create all of these. You can subtract cosine squared from both sides. You can subtract sine squared from both sides. You can divide every term by sine squared. You can divide every term by cosine squared. You can create all of these just by knowing this one. My tip is if you see something squared minus 1 or 1 minus something squared, you're likely looking at a Pythagorean identity. So if you don't know these, screenshot this and keep it somewhere handy. Your reciprocal identities. Remember, you have to know your basic trig identities. Sine of theta is equal to 1 over cosecant. Cosecant and sine are reciprocals. Cosine of theta is 1 over secant of theta. Cosine and secant are reciprocals. If you have a hard time remembering these, just remember they will never start with the same letter. Sine goes with cosecant, cosine goes with secant. And tangent, of course, is 1 over cotangent, but we really don't think of tangent as 1 over cotangent. It is much more helpful to think of tangent as sine over cosine, and therefore think of cotangent as cosine over sine. Remember when we were simplifying trig identities, it really helped to get everything in terms of sine and cosine. That's why these identities for tangent and cotangent are so much more helpful. All right, let's just dive in. We are going to verify that secant squared of theta minus 1 divided by secant squared of theta is equal to sine squared of theta. So you have to take these step by step. And remember, I said we're going to work only one side. So I'm going to kind of draw a little T. I'm going to draw a line right down beneath my equal sign. And I'm going to figure out which side I'm going to manipulate or which side I'm going to work. Remember I said we're going to simplify the more complicated side. So we're going to take this secant squared theta minus 1 over secant squared theta. And we are going to try and manipulate it so that it equals sine squared of theta. So since we're trying to create sine squared of theta, we are going to, every time we get a chance, put things in terms of sine and cosine. So what should we see? Well, secant squared theta minus 1. Remember, I just said if you see something squared minus 1 or 1 minus something squared, you should be thinking Pythagorean identities. And that works here. We should remember that secant squared minus 1 is equal to tangent squared. So I can replace the entire numerator with tangent squared. This tangent squared is going to replace secant squared minus 1. That's why it's really good to know those Pythagorean identities. So now I've got tangent squared over secant squared. I'm going to write everything in terms of sine and cosine. So tangent squared will become sine squared over cosine squared. And remember, secant is the reciprocal of cosine. So secant squared will be 1 over cosine squared. So let's look at those. I'm going to rewrite tangent squared in terms of sine and cosine, and I'm going to rewrite secant squared in terms of cosine. When I do that, it'll be ugly for a little minute. You're going to have a fraction that has a fraction in both the numerator and the denominator. But not to worry, just like we've always done with fractions, when you are dividing a fraction divided by a fraction, you are going to take this fraction and multiply by this reciprocal. So you're going to take the numerator and you're going to multiply by the reciprocal of the denominator right here. Now, when you set it up that way, look what happens. Cosine squared of theta is going to divide out. So let's just cancel that out right now. We're left with sine squared over 1. Sine squared over 1 is simply sine squared of theta. What were we trying to find? We were trying to find sine squared of theta, or we were trying to create that. So sine squared of theta does in fact equal sine squared of theta, and we have verified this identity. All right, let's try another one. Here we have cosecant squared of theta minus cotangent squared of theta all over tangent squared of theta times cosecant squared of theta, and it equals just simply cosecant or cosine squared, we hope. So guess what? The more complicated side again is going to be that left side. Let's put our little bar here. So we're going to work that left side and try to get it to equal cosine squared. All right, we're going to use our Pythagorean identity, and we're going to try and create something that equals cosecant squared. Because we have a cosecant squared right here, we have a cotangent squared too. Let's see. Let's look at our Pythagorean identity. If we have cosine squared plus sine squared equals 1, and we divide everything by sine squared, cosine squared divided by sine squared is cotangent squared. Sine squared divided by itself is simply 1, and 1 over sine squared is cosecant squared. I really liked using this because I saw cosecant, so I knew that was 1 over sine squared, and I saw cotangent squared, so I knew that would be cosine squared over sine squared. So I'm simply going to say cosecant squared is equal to this, cotangent squared plus 1. And I know you're thinking, well, you're replacing like this little one monomial with a binomial, 2 terms. But watch what happens. When I do that, cotangent squared plus 1 minus cotangent squared is what I get in the numerator. I replaced cosecant squared with this guy right here. So what's going to happen? Cotangent squared minus cotangent squared is going to be 0. I'm simply going to be left with a 1. So now what's in my numerator? 1. So I have 1 over tangent squared of theta times cosecant squared of theta. I haven't even looked at the denominator yet. But I do know that I can write tangent squared in terms of sine and cosine, and I can write cosecant squared in terms of sine squared. And that's what I'm going to do. Let's remind you, tangent squared is sine squared over cosine squared. Cosecant squared is 1 over sine squared. I'm simply going to take this and replace tangent squared, and this and replace sine squared. And look what happens when I do that. Sure, it makes my denominator a little ugly, but I can now divide out sine squared. So when I do that, I have 1 over cosine squared. So 1 divided by a fraction. That's okay, because I can simply take 1, my numerator, and multiply by the reciprocal of the denominator, just like I just did. So I'm just going to have 1 times cosine squared over 1, which is going to be cosine squared. Cosine squared was what I was trying to get. Cosine squared of theta does equal cosine squared of theta, and I have verified this identity. All right, let's do another one. Let's do one more. Here, we don't have a single one term on one side. All right, so we have secant of theta plus tangent of theta equals cosine of theta over 1 minus sine of theta. So it's not really clear that one is so much easier or so much cleaner than the other side. So you're going to start with the right side because I can make a Pythagorean identity from this denominator. When I see 1 minus sine of theta, I know I can make this into a Pythagorean identity, and you're going to see why in a minute. I would probably start with this side anyway because it has a fraction, and this is always going to be more complicated than secant plus tangent. All right, so we're going to work with that right side. When I said I could make a Pythagorean identity, what I'm going to do is multiply by, if you remember, the conjugate. I'm going to basically take a sum and difference here. I'm going to multiply 1 minus sine times 1 plus sine, and then I'm going to get 1 minus sine squared. But I have to multiply the whole fraction. I have to multiply this whole thing by 1 plus sine over 1 plus sine. I just can't multiply my denominator willy-nilly, okay? So that's what I'm going to do. So I'm going to do that to the right side. I'm going to have cosine of theta over 1 minus sine of theta, and I'm going to multiply by 1 plus sine of theta over 1 plus sine of theta. Remember, this is just a glorified version of 1. I'm not changing the value. 1 over sine plus over 1 over sine, or 1 plus sine over 1 plus sine is 1. I'm just multiplying by 1. It's a really unique 1, but it's 1. All right, so what we're going to do is we're going to keep the numerator in factored form, and we're going to write that denominator as our Pythagorean identity, which is nice because I don't have to distribute my cosine of theta just yet. We're just going to write cosine theta times 1 plus sine of theta, and then we're going to write it all over 1 minus sine squared. All right, now what do we see? Well, I wanted to write 1 minus sine squared because 1 minus sine squared is equal to cosine squared. Got to remember those Pythagorean identities. 1 minus sine squared is cosine squared. So that's what we're going to put in the denominator. Now I have cosine times 1 plus sine over cosine squared, and I can simply divide out a cosine of theta. So cosine of theta divides into cosine squared of theta, leaving me a cosine in the denominator. Fantastic. What do I have now? I have 1 plus sine of theta over cosine of theta. Let's try to remember what we have to get. We have to get cosine over, well, we started with cosine over 1 minus sine of theta, and we have to get it to secant plus tangent. Right now I have a fraction, and I got to get two terms added to each other. So what I'm going to do is say, well, maybe I could split this fraction up. 1 plus sine of theta over cosine of theta really is 1 over cosine plus sine over cosine. And that might actually help me. Remember, there are times where you can go through these entire problems and go, well, that didn't work, and start over. But think about where you're trying to get to and how you can do it with each step. So we're going to do 1 over cosine plus sine over cosine. All we do is break up that fraction, right? We wrote it as two separate fractions because that's really what it is. These are equivalent. I haven't done any math. I just rewrote it. All right. What's 1 over cosine? 1 over cosine is secant. What's sine over cosine? Sine over cosine is tangent. Look at that. I'm done, and I didn't even know it. I got secant of theta plus tangent of theta, which is exactly what I was trying to get, working the right side of this equation to look like the left side. So those are verifying trig identities. If you have questions, pop them in the comments. Send us an email. I know these are tough. You just have to kind of keep at it, and they will get better. You know what to do. If this video helped you, great. Go to our YouTube channel, subscribe, send your problems in, and the next video I make will be for you. Till next time, take it easy.